Okay, this example is from the first section of chapter 7, when we use Avogadro's number to convert between moles and numbers of representative particles. Propane, C3H8, is used for heating and cooking. How many representative particles and how many atoms are in 2.12 moles of propane, C3H8? So this is a two-part problem. The first one is representative particles. So we need to write down our givens to begin with. That's where you always need to start. And here we're given that we have 2.12 moles of propane. What our unknown, what we're looking for, the first one is representative particles. And to do that, we know that 1 mole of anything is equal to Avogadro's number of that thing, 6.02 times 10 to the 23rd. In this case, because this is a molecular compound, it will be molecules for the representative particle. So now our conversion factor could either be 1 mole of propane over 6.02 times 10 to the 23rd, or 6.02 times 10 to the 23rd molecules of propane over 1 mole. We set this based up on what our unknown is, what we're trying to get. In this case, we want particles. We're given moles. So if you start with 2.12 moles propane, you always set your conversion factors up so that the thing that you're trying to cancel is opposite from itself. So we want 1 mole of propane on the bottom, 6.02 times 10 to the 23rd C3H8 molecules. Moles of propane cancel out. And when you multiply 2.12 times 6.02 times 10 to the 23rd, when you do that, you're going to say 6.02 and use the exponent button and then 23. So make sure you're using the button that either says EXP or EE on it. Don't do times 10 to a power or your decimal will always be off 1. This button means times 10 to that power. When you multiply 2.12 times that, 6.02 times 10 to the 23rd, we get 1.28 times 10 to the 24th. You need to make sure that you're putting this stuff in a calculator so that you make sure that you're doing it right. And that will be molecules of propane. That's answer A. Put a box around your answer so I can find it. Because if I have to look for it, I'm not gonna. And to go from molecules of propane to how many atoms there are, you've got to look at this molecule, C3H8. We've got 3 carbon atoms and 8 hydrogens. So every molecule of propane has 11 atoms in it. So if we say 1.28 times 10 to the 24th, well, that was dumb. Molecules of propane. Here we're going to use that 1 molecule of propane, so we put that on the bottom to cancel. Has 11 atoms in it. So that's 11 atoms per molecule. That's what that's saying. Molecules of propane cancel, and when you multiply that times 11, you get 1.41 times 10 to the 25th. That'll be total atoms in 2.5 moles of, that's the wrong problem, 2.12 moles of propane. So again, we went from moles, use the conversion factor of Avogadro's number to get to representative particles, which are molecules. Then we can take how many atoms, which are 11, in that molecule to find out how many atoms are in the whole thing.